Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate. So this time, I'm going to try doing it with a different function. So on the right here, I have f of x. So this is in standard form, and the reason I know it's in standard form is because it fits this structure. I have an x squared term, an x term or linear term, and a constant. So let's identify what are my ABCs. A is the leading coefficient, in other words, the number that's in front of the highest term with the exponent. So this is x squared, so my A is -5. By the way, don't assume it's always first. These terms could be rearranged in a different order to try to trick you. So remember, the A is always the number in front of the x squared term. B is always the number in front of the x term, so it's -1. And C is always the number completely by itself, or the constant. So we can see here that our A value is going to be a negative number. And remember, if the A value is less than 0 or negative, it's going to be concave down. So we already know the concavity is down. Now remember, the other benefit to having a standard form is now we know what the y-intercept is. So the y-intercept is going to be the C value. 0, comma, and then whatever that number is. So I look here and I realize it's +21. All right, so this is all that standard form gives me. So we're going to go to Desmos now and we're going to graph this. Here we go. So this is kind of what it looks like. You can adjust the viewing window and adjust with the settings and the access and so forth here to help get a better view. So like I might actually change this to say -10 to +10 here. And then now I have a nicer view of my picture. So notice right off the bat here, if you see right away, our function is concave down, which is exactly what we expected. So let's go through our characteristics. So what is the domain? As before, the domain of every quadratic is always all real numbers. What is the range? Okay, now the range in this case is going to be different. It's going to be opposite from this range here. In the previous function, we had a minimum value, so the range had a lowest point. But when you look at this function here, this quadratic, this parabola, is concave down. That means it's going to have a maximum. So the range is actually maxed out. Well, what is it maxed out at? Let's click on it. What is this highest value? Let's be careful, we don't want the y-intercept, right? So there's the highest value, and it's 21.05. So I'm going to need to give myself a little more space here. 21.05. That is the maximum. Well, what's the lowest? Well, it's concave down, right? It's just going to keep going and going. So it has no low value, so it's -infinity. And remember, on any of the infinities, whether it's negative or positive, it always gets parentheses. You cannot include it. In other words, do not put brackets on infinities. A bracket means you can actually include that number, and infinity is not a number, it's a direction. All right, let's keep following along. Vertex. So my vertex is my highest or lowest point. I can see here my vertex is going to have a high point. Okay, right there. So my high point is -0.1, comma 21.05. Again, rational numbers, which is fine. If we know the vertex, we know the axis of symmetry. Do you remember up here? So remember, the vertex and the axis of symmetry are connected. So the axis of symmetry is that vertical line that will cut straight through, and it makes it symmetric, both sides symmetric to each other. And so the axis of symmetry is the x-coordinate of your vertex. So in this case, it's -0.1. And if I actually type that in, let me show you. So x equals -0.1. You can see right there, it's going to go through vertically there, and it's going to be symmetric to the graph. Okay? All right, let's keep going. So we have our axis symmetry. Okay, let's do our x-intercepts now. So let's see. We have this one and we have that one. So I'm going to write those down. -2.152, 0 and 1.952, 0. So there's my x-intercept. Now, the part that's probably the most difficult is when is it decreasing and when is it increasing? So these are intervals. So we're talking about when that happens. And remember, when is referring to the x-axis. So, decreasing. So when is it, let me unclick those, let's zoom out. When is it decreasing? Well, the values are going down right here. This is going down, right? Imagine this is a hill. When is it increasing? On this side. When is it decreasing? On that side. So when does it start? When is the x-axis? Use the vertex. Remember, we're going to use the vertex, the x-coordinate, see right here, to describe our increasing and decreasing intervals. So my x-coordinate is negative 0.1. So the decreasing is going to start there, and it's going to continue to positive infinity. How do I know that? Because the graph just continues to drop on the right side there. So if this right side is decreasing, then this means the left side must be increasing. So when does it happen? Well, it's coming from the negative infinity side. So it's coming all the way up. So we're going to go negative infinity all the way until we get to that vertex, and we want that x-coordinate there, which is negative 0.1, and it is not included. Now, make sure you make a note in here that you need to use Desmos to graph. Okay, but that's how you can do it. Again, to recap, so standard form gives you concavity and the y-intercept. Okay, good luck.